This is Saxon's Trigonometry, Lesson 1, beginning on page 1. I will not be able to cover all of the sections in this video, but starting with Section A, Points, Lines, and Rays, we begin with discussing some terminology. And in math, we basically refer to certain elements as undefined terms. These are also called primitive terms. That's the non-mathematical way. But the undefined terms are things like a point. We do not have to define that that represents a point. If I take a series of points and I connect them and they're not in a straight line, then I've created a curve, also not really defined, just sort of shown. If I take some points and they are in a straight line, then I have created a line continuing on in both directions. And the final one is called a plane, and it is any flat surface, often represented with a rectangle parallelogram of some sort like this. And we'll talk more about that in just a moment. But those are your undefined terms. Now, if we take 2 points, there is only one line that is possible to be drawn through both of those points. I can't go this way and then bounce back down. That's not a line. That would be 2 different lines. So the only line I can draw through would go that direction. Now let's label these points A, B, and M if I want to follow the example in the book. So if I want to name this line, it requires me to list 2 of the points. And it does not matter in what order they go. I can also jump over other letters. So I could choose to name this line AM or BM. Don't usually use that one for obvious reasons. I can also do AB. Now there's a symbol that needs to be with those letters that designates this as an actual line. And it would be the symbol of a line above them with arrows on both sides. And that's important to designate it an arrow on both sides, indicating that a line goes forever in both directions. Then, if I want to talk about only a segment, a start and a stopping place in the line, so if I want to go from A to B segment, I draw a segment line above it. Now, it does not have to have the dots. In math, we determined that just the line above is sufficient. Also, A to M, if I want to go all the way from A to M, that would be the segment name. It could also be M to A, B to A, those are the same things. And now turn to page 2, and you have, if I use this symbol, an equal sign with a squiggle above it, it's indicating congruency. Both lines that I would be talking about if I said something like segment AB or line AB, that should be segment. Segment AB is the same as segment BA. It's congruent to segment BA. I am trying to indicate that with this symbol that it is the same shape and size. So this symbol for congruency. It is the same thing if I wish to say the measure of AB is equal to the measure of BA, both of those being segments. So if I don't use the congruency symbol and I use the M, I'm standing for measure of. So however long this segment is the same length as this segment. Or I can say that they are the same shape and size and use congruent. Okay, then at the middle of the page, they shift gears and they talk about rays. Now, a ray is showing that I have a starting place and I go forever in one direction. So if I wish to start at B, this one is important, the order of the letters, then B through M as a ray has an arrow only on one side, which is why it was important on a line to put the arrow on both sides. I could not say MB, ray MB, and that would mean I'm starting at M and going this direction. I can't flip the letters. So it's very important, whatever the letter is where I'm actually starting. Now, what if I say I want ray B through A? I'm going to label it with the same ray symbol, arrow still on the right-hand side, never on the left-hand side. I don't need to match that with whatever the picture is showing. The understanding is that this letter is my start, the next letter is one I'm going through. So if in the picture it goes this direction, that's great, but the symbol for ray will only put the arrow to the right. Okay, at the bottom of the page, we have intersecting lines, and the two lines can cross. They're going to cross at one point if they're intersecting lines. And then on to section B, beginning on page 3, we talk about planes. So up here, if I wish to label this plane, I'm going to do it with a capital letter in a corner. And it doesn't matter which corner, as long as it is a capital letter, I'm naming a plane. And so we don't need a special symbol with that. If you just use the capital letter P and there is a plane in the picture, you are to assume then that is plane P. However, if I use a capital letter M and I do not see a plane but a line in my picture, then I'm indicating a point. And points can be capital or lowercase letters. Mostly in this book, they will use capital letters, so that can be potentially confusing. All right, so if I have these two intersecting lines and they are drawn within a plane, then I say that they are coplanar because they are in the same plane. Co meaning same, planar being plane. I can have in the same plane parallel lines, which means they run in the same direction. Lines should have arrows to be precise, here and here as well. So these would be parallel, running in the same direction always. They are also coplanar because they are in the same plane. If I draw a plane and I have a line in the plane, but I have another line that kind of shows as a dot here and then dash lines to indicate it's going through it, then this line is not in the plane, it's going through the plane. And so we would call these lines skew lines because they are not sharing the same plane. All right, in section C, at the bottom of page 3, we begin to discuss angles. And an angle is two rays connecting from one vertex point, one shared endpoint, and that makes an angle. Let's label some things here, A, B, and C. How can I name an angle? So we are going to use the angle symbol, which is this symbol, and I will clarify that the bottom of this must be flat in order to be an angle symbol. If I draw it not flat, that is your less than symbol, to say something like 3 is less than 4. That's when it's slanted. So it's very precise that the bottom of an angle symbol should be flat. Now, you can name an angle with just its vertex letter, one single letter, and this would be labeled angle A. It could also be BAC. I can use 3 letters. The critical point here is that the vertex point, shared point, needs to be in the middle of the letters. So I could also say that this is angle CAB. That's how I can name the angles. Now at the top of the page, they talked about if I choose to say that this is my starting ray, then this is titled the initial side. And then the gap would be a certain amount of degrees. So we could label that 30 degrees. And then that would mean that it's stopping, going from here to here. This would be the terminal side, the end side. And I can also have an initial side and go on the outside and make this my terminal. And if I do, and the inside gap is 30, I'm forming a full circle, which is 360 degrees. So the subtraction of that would mean that the exterior angle here would be 330 degrees if the inner one is 30. Same thing applies to angles as applies to lines, where we can have the measure of an angle is equal to the measure of another angle, or we can use the congruency symbol, and we tend to default to this one more often just because it's a little shorter than putting those M's in front of everything that we're doing. And at the bottom of page 4, we talk about the terminology of the names for angles. So if it is a straight line, it can also be called a straight angle. So a line is a straight angle. If they cross and my angle forms 90 degrees at the corner, then I guarantee that it is a right angle, only if it forms that 90 degrees. And then if it is less than the 90, then we call it acute. And if it is more than 90 degrees, it is obtuse. And one of the ways to remember that is our English word, you are obese, obtuse. They're very similar, so that is one way that you can potentially remember. And acute is tiny or sounds tiny. That's a cute little angle. It helps you remember. Okay, then, oh yes. At the very bottom of page 4 and starting up into page 5, we have two very special terms that students often have a lot of trouble remembering, and so I try to give you a cute way to remember it, I hope. And they are the words supplementary and complementary. I ran out of space, but you can figure out how you finish spelling the rest of that. Supplementary and complementary. Supplementary begins with the letter S, and so if I wish to form it with some mass symbols of 90 degrees and an extra little tab at the bottom forming an S, 90 plus 90 is 180 degrees, and that helps me remember that supplementary angles means I have two angles that are forming 180 degrees. 180 is a line, so if I have two angles that together are forming a line, then they are supplementary angles. In your homework questions, it will say statements like, X and Y are supplementary angles. What you will write for that equation is X plus Y equals 180 degrees. And then you'll be given other information in the problem to continue. Complementary works the same way. If I take the 90-degree symbol and add little tab at the bottom, I formed a C for complementary. And since that is a right symbol, 90 degrees, it means that two angles are forming 90 degrees. So if this one's X and this one's Y, I will be saying X plus Y equals 90 degrees. And you see some more examples of those on page 5 where you get to play with the different equations that you're putting together in order to solve for some angles. And the final example there on the top of page 5 is where you have the vertical angles. And what you need to know here is that vertical or intersecting lines form vertical angles is the better way to say that. So this one is considered vertical to this one. They will always have the same measurement. This one is considered the same as this side. They are vertical angles, therefore they have the same measurement. So the example there in the book, your equation would say Z equals 3Z minus 80, and you could solve that by putting your z's together on one side and your 80 on the other. So just as a quick algebra review, I would normally choose to move this z over to this side. However, I realize that's going to leave me a negative 80, so I'm actually going to swap everything. Moving the 80 over to this side, making it positive. Moving the z over means I minus a z. 3 minus 1z is 2z. And then we separate the 2 from the z by dividing, and that means you will have z equals 40. And it's not a measurement and it's not an actual degree, so we're just going to say z equals 40. We will pick up in another video with section D.